This is The Future Of, where experts share their vision of the future and how their work is helping shape it for the better.
Hello, I'm Sarah Talia. Imagine we could harness the power of good gut bacteria from healthy people to fight off stubborn gut infections in others. That's exactly what we're exploring today with a game-changing approach to gut health, fecal transplant capsules. We get the ick factor, but this treatment, being trialled by Dr. Hani Al-Salami and Dr. Amin Moranian from Curtin Medical School, is yielding extremely promising results in treating seriously debilitating gut conditions. In this episode, we discuss Curtin University and Australian Red Cross Lifeblood's development of fecal transplant capsule for Australian clinical trials. We look at common gut disorders where current treatments fall short, and how gut biota from other people can be the panacea for your body. If you'd like to find out more, you can visit the links provided in the show notes. Let's start at the foundation of it all, the gut. It's often called our second brain, and for a good reason. Could you shed some light on why maintaining a healthy gut is so important to our overall well-being? I'll start with you, Anmin.
The gut plays a central role, a very important role in the health and balance of the body. Traditionally, the gut was thought of, you eat your food and go to the toilet. But that thinking and mentality has changed over the years a fair bit. We now know the gut is actually quite important in maintaining the entire body as a whole. In actual fact, even the brain. It responds very well to the gut, and the gut is made up of lots of different things that actually help the body to get on with its everyday activity.
When we're talking about what is actually in the gut and what it's made of, there is that complex world that's really going on of gut microbiota. What is that? How does that actually fit into the picture?
Gut microbiota is the microorganisms or bacteria, what have you, that are good and friendly to you. They naturally live in the gut. We're all born with it, and in actual fact, we have 3 times more bacteria than human cells. So human beings are more bacteria than human, if you think about it. So these good healthy bacteria live in your gut, you are born with it, and they do change over time. For example, if you have a certain disease, there is an imbalance between good and bad. Diet plays a very, very important role, the dietary sources of good bacteria as well. But these bacteria, they're very different, multiple species of them, have an important role in keeping you healthy, the fighting of bad bacteria that you come into contact with, and also regulating everything else in the body. And we now know it's everything to do with your immune system, your metabolism, your mental health as well. You've heard expressions that, if you have a diet full of fast food, for example, you do feel a bit down. That's been said as well. That's actually evidence that it changes the bacteria, the microbiota of your gut, favoring more bad bacteria and signals being sent to the brain than good.
So what are some of the common intestinal issues, and can you just describe how the current treatments work, what's on the market at the moment?
So there's lots of things that can go wrong with the microbiota of the gut. So the most obvious one is when you're taking antibiotics. Antibiotics do kill bacteria, but they can't choose between good or bad. So one of the side effects is diarrhea. We also know that the microbiota is disturbed by alterations in the diet. So we said like bad diets, fatty food takeaways do give the upset tummy as well. But in addition, you do have more chronic conditions, so irritable bowel syndrome, irritable bowel disease, where you have this permanent, if you like, disruption of the microbiota that then also damages the lining and tissues of the intestine as well. So there's lots of ways to go about it. Traditionally, we've been looking at probiotic supplements. You see them on the ads on TV all the time, the good bacteria in a capsule, but they're dietary sources of that as well. So yogurt is also full of good, healthy bacteria. And then there's the FMT concept, which is the fecal microbial transplantation, that is transplanting the bacteria, so getting healthy bacteria from a donor and putting it into a recipient, someone who is in need of that. So there's many different ways of approaching and trying to restore the microbiota of your gut.
Armin was just talking about some of the common ways that people try to really look after their gut health. What really makes this approach with using this special capsule, you're going to tell us all about what's actually inside this capsule. Why is this better?
Okay, so notionally, we've always believed that the probiotics, which is selective species of bacteria, we can just deliver them in capsules, and they're going to go in and they're going to colonize the gut that doesn't happen. So that happened for a few reasons. The first one is our body, we evolved not to take all the bacteria. That's why the stomach is so acidic. And the reason why it's so acidic, or one of the reasons, is because it's evolved to kill bugs. So we don't have them in our body. The second reason is the microbiome is not bacteria. It's very different. Microbiome, as Amin said, is actually up to 10-fold more bacteria than our own cells. So in last conference I was presenting, I said to them, look, you can look at us as human with lots of bacteria or as bacteria with some human cells. So these are the two options. And the reason is because it's bacteria, it's viruses, it's fungi, it's all the other things which we believe they have bigger impact than just purely the bacteria itself. So the bacteria produces polypeptides, it produces a lot of chain fatty acids, they produce a whole raft of soup, if you wish. That soup we believe to be fundamental in reconditioning the gut into a healthier one. So as Amin described very well, that disease conditions are influenced by the health of the person, but that health for the person can then influence the gut itself. So you have this kind of tsunami of problems causing more problems, these problems cause more problems, and so the body is damaged, the bacteria is damaged. The second thing you need to bear in mind is that the control of the communication between bacteria and virus and the gut itself with the body is quite significant and well documented. So if you look into our gut and zoom in really close, you will see that the intestine, there's lymph nodes and there is immune cells that can extend the arms pretty much into outside in a sense that that bacteria and the soup in there can influence the way they communicate with the brain, and hence the gut-brain axis. So that's why so far just giving one or two types of bacteria, we believe that they're best, in a capsule, that's not going to work. And so far it has failed to treat disease. I mean, it might help, but we don't have a clinical indication of just probiotics to treat a disease and that's it. Not only this, if we take antibiotics as Amin said, and that's the whole purpose of it. So at the moment, the FMT is being indicated clinically for people who had really bad infection, a hell of an antibiotic dose, and then get invaded by a bad bacteria that colonize the gut. And the death rate is quite high in these conditions.
Oh, wow. So what type of conditions can result from that?
So for example, there's something called Clostridia difficile, or Clos diff in short. And that's a type of bacteria that exists, but if you let it rip, it will destroy you, and it will kill you, basically. So hence, the only treatment that's been effective is pretty much getting someone's poo, which has got bacteria, viruses, fungi, the whole soup, and transplant it into there. And that seems to be the life-saving approach. The problem with that is what currently happening is the transplantation process is through colonoscopy, which means not everyone is eligible, which means it's very invasive, which means it's got risk into it. So you can't just willy-nilly give it to anyone that's got the problem. That's hence what we came up with, which is the capsule designed specifically to handle sufficient amount of these bacterial content or gut content. It's taken orally over a couple of doses, for example, so maybe 20, 30 capsules now and the same thing tomorrow in the clinic by a specialist, in the presence of a specialist, then that can transform the gut conditions of the patient from suffering into a healthier, happier gut.
What does that transition look like from someone who's starting off with a terrible gut it's really stripped and struggling to that evolution towards a healthier gut? What does that journey look like?
So there's a famous YouTube where a guy called Kevin Cross. He thought he was dying for sure, and he got the stage where he's just waiting to die, and all of a sudden, after one dose of MT, he is healthy and happy as he ever can be. So I was shocked to it myself. I didn't expect to see that massive impact, but that's what drives us. We're both clinicians. We both worked in hospitals and pharmacies before. We know what it's like. In fact, that's all what you do. You deal with patients. People don't go there because they're happy and healthy. They go there because they have a problem. So to see a transformation like that, that's what drives us, because we can give back to the community and ensure that all the training and all the investment that we had over the years is paying off to our clients, our patients, our people. That could be mum, dad, and so forth.
So when we are actually looking at this fecal microbiota transplantation, this little capsule, can you talk me through, either of you, how that process actually starts, and where do you actually, how do you identify a good donor?
Yep. So the Red Cross, and I can't speak on their behalf, but we work very closely together. They have a very thorough process to make sure that they screen the candidates. So we're blessed enough and we're lucky enough that people will go there and will donate. They donate their blood, their breast milk, and now it's feces. And these people get screened, and that is one of the challenges that we have, is actually, because it's such a stringent screening process, very few make it. So you end up with the feces, and then what you have, so the healthiest, and they may sound quite gross, but the healthiest feces are the most fresh one. They can take it straight from the toilet straight to someone's mouth, basically.
Wow.
So the faster the better. And that's why we're now creating a platform at Curtin, I believe the first in WA, that will have the ability to kind of expedite the process, because at the moment it's so manual. So you take it, then you filter it, and it's amazing how people can have different pool types. But you can have chunk, you take the chunk out, you dilute it, you add something to it, and you basically just put it straight into the freezer, -80 freezer, and then they give it to Fiona Stanley hospitals and all this, and they thaw it, put it in a syringe, and inject it in. That's it.
They inject it straight into the capsule?
Yep, so the syringe, you have a very good size, no, the capsule. This is the transplantation through the colonoscopy.
Yes.
The capsule will be very similar, but what we're hoping for is we take so at the moment that's what we're working on. We just started the process, the project itself, and the idea of it is to finalize what's the best process and platform that we can use to maximize outcome. So maximize outcome means we have a robust capsules, they're uniform, they're consistent, they've got enough amount of fecal matters, and that is done so quickly that we don't lose out on good stuff, because a lot of bacteria die the minute you poo, because half the poo is bacteria. So when you think about it, and we have about an average about 1 to 1.5 kilogram of fecal matters on us all the time. So basically, the minute it comes out of the gut, it's already in a hostile, different environment. And the question is, how can you save whatever is there by making a process so seamless, so quick, so smooth, that we can have it, put it in the capsule, and then give it, and then put it in the freezer. And what will happen afterwards is we will deliver it to the hospitals, where GPs can give them to patients and even nurses.
That's an incredibly interesting process, especially with how fast you really need to be getting your hands on that stool. I really want to touch on the ick factor, because I think it's something that we need to unpack. But there is quite a stringent cleaning process that you talk about, the screening process that goes on. How do you address the ick factor if you're at a barbecue and someone says, "What? You're doing what?" How do you approach that?
Look, in actual fact, it's not any different to the medications and drugs that are in the capsule at the moment in the market. If you were to actually walk into a pharmacy, grab a capsule off the shelf and open it and look at the powder inside, it is very disgusting, very smelly. But you don't actually feel that unless you chew your way through a capsule. So this is actually no different. And the evolution of the pharmaceutical industry over the years has designed delivery system dosages, capsules, of various ability to actually hide, if you will, the odor or the ick factor that you get. And this actually, before we even get into the concept of FMT and microbiota, we had these problems with drugs. Antibiotics or everything like that are actually just as disgusting. It's just that they don't have the stool factor associated with them, but rest assured they can be just as disgusting if they do come into contact with you. So we were able to take these technologies that have naturally evolved over the years and apply that to the FMT space. The ick factor is actually can be further dealt with, if you will, by many things you can add to the capsule, to flavor, to color, to have that enhanced appeal for the general public. And look, there have been many studies done that if you were to sort of blindfold people and just give them a capsule, the mind can play a lot of tricks on you. And if you actually do not disclose what is in there and say, "Yep, this is a jelly bean," people, "Yep, this is a jelly bean." So it's
we're not going to do that.
We won't be doing that. But the amazing thing is, with the science has advanced so much that you're able to add many things to this pot of mixed soup, if you like, that is able to make it much more pleasant for the recipient, for the patient.
How significant is the potential of this pathway?
The pathway to code it or to the treatment modality?
It's extraordinary.
Oh, either.
Well, yes, extraordinary is one way to put it. Absolutely. And look, the interesting thing about this is that it's a collection of things that make it effective. So it's, people have tried to take poo, stool, and isolate the good bacteria from it and give that to the patient. It hasn't worked as well. Likewise, sterile poo that's had the bacteria removed doesn't work as well. So it seems to be a combination of things. And we don't know at the moment. This area is rapidly evolving. We think that it's the combination of bacteria plus what they could possibly secrete in that stool environment that as a combination delivers that medical benefit. And look, it's been applied traditionally in the local space. So what we mean by that is in the gastrointestinal gut area to treat things with Clostridium difficile, which is a bad bug that people can get, but also inflammatory bowel disease, which is becoming more prevalent, IBS, IBD. You might hear terms of ulcerative colitis and Crohn's disease, these sort of things. But the beauty of this technology and this application of FMT microbiota is that, as Hani did mention, the gut-brain axis, we're able to diversify that treatment into much or more diseases. We know that from our experience as clinical pharmacists working in community and the hospital space, that one area of example is Parkinson's disease, which is a neurological condition that's characterized by shaking and tremors. And very most famous case out there is Michael J. Fox, the young actor who was diagnosed at the age of 29. We've seen from our own practice that a couple of years before the actual clinical diagnosis of Parkinson's disease, the shaking tremors, people complain of problems with the gut. Constipation is a very big, and they come to the pharmacy, all sorts of remedies, and doesn't do the trick. So this reinforces the fact that your gut is actually talking to the brain, saying something is wrong. And this is then expanded into the areas of Alzheimer's disease, which is one type of dementia, your forgetfulness, and also multiple sclerosis. We now know that diabetes, before you get your sugar levels going very, very high and seeing the doctor, actually starts off with your gut playing up, where there's a change of bacteria, the bad bacteria from years and years of bad diet is taken over, and this bad bacteria is sending signals to other organs in the body, making you resistant to glucose, needing treatments to help with the sugar levels and so forth. So we've been able to, over the years, to look outside of the gut space and to use that FMT platform for multiple diseases as well.
I didn't realise how expansive its potential really is. So,
that's what I always tell my students and patients is that type 1 diabetes is a very good example, because the type 1 diabetes, people believe, or scientists believe, that it starts within 6 months of life as an insult in your gut that confuses the immune system, and it lasts until you're 19, 20 or 17, so many years later. But then your pancreas is wiped out, so you've lost 90% of your pancreas by then that's when you get recognized as a diabetic. But what would happen if you saved it early? So these are the kind of things, and I know it sounds gross, but it starts from the mum, because you get your gut bacteria from your mum during birth. So would that mean that if you condition the mum's gut correctly, would that give you a healthier baby? And I'm not giving any promises or anything whatsoever. We're just starting this work. But that's how far it goes.
And it's applicable to a range of patients, not just the adult population, but also in the pediatric children's space as well. There's data emerging that some common conditions like autism has been found to have disturbances in the gut. So that gut-brain axis is becoming more and more critical in everyday practice.
is there anything, I know that this is not specifically what we're here for today, but is there anything that you'd recommend, simple things that we can do to look after our guts?
Most important thing is to try and keep the microbiota, the good bacteria, happy in your gut. And there's evidence to show there are lots of things you can do. A good diet is first and foremost the most important. Things you don't have control over are obviously genetic factors, but you'll be surprised the genetic factors actually constitute a small amount in the overall problem with the gut. Our environment and personal decisions actually impact hugely. So diet is a very important one. That good old every GP says this: diet and exercise and don't stress. They've all been associated with a bad gut. You know, if you're stressed, if you're eating a lot of junk food, for example. So yeah, a lot that you can do with a diet. Whereas a good diet, it's been shown that processed food is best avoided as well. And as we find the processed food is becoming more predominant in the Western diet and Western societies, we're seeing a direct correlation to microbiota change in the gut, and this is translating to more and more prevalence of a lot of conditions. No, it may not be as black and white directly, but it's definitely an important factor to consider as well.
It's very complex. So I just say that the conditioning of the gut is a very tricky business. And even identifying what's good and what's bad is a very tricky business. And identifying whether your intervention is the reason for healing is also a tricky business. So as you can see, there's layers and layers of complexity. That's why you cannot just get it prescribed from a doctor. You cannot just go to your GP and say, can you give me some FMT capsules? It has to be set in a clinic, proper way, a condition. So, and especially in children, that becomes very complicated. But we're trying our best, I guess.
I'll ask one more question about the alcohol because I think that's really interesting.
Yeah, alcohol's effect on the body are a bit too diverse, and I guess the difficulty comes about saying the chicken or the egg. Was it alcohol, which has been proven to increase the blood-brain barrier permeability? So, but basically, your your brain has this wall, right? Think of this wall. Alcohol basically takes the bricks away and allows the bad guys to get in. So if the question becomes the whole important thing about the gut-brain axis, what's alcohol's effect? The question becomes like chicken and the egg, did the alcohol cause the brain to become more leaky so things get in? Or did it damage the bacteria, which then indirectly led to that? So we don't know. And to do a study on that is actually quite difficult.
Almost impossible, I would say.
Yeah.
To be accurate.
So it's because its effect has been shown to, it promotes cancer. It makes the brain more susceptible to bad things getting in there. So alcohol consumption has been linked to Parkinson's, Alzheimer's, just purely on its own, even with the healthiest of diet. So singling out what it can do, because it does so much, that's why the general consensus is don't drink.
Hani, every researcher has a story and maybe a moment of inspiration that propels them into their field of study. Could you give us a glimpse into what drew you towards the niche of pharmaceutical encapsulation and specifically the development of FMT capsules?
Okay, thank you, Sarah. And that's a good question. So as a pharmacist, I went to school of pharmacy. I've always wanted to be a pharmacist. And I've graduated and did my internship in a pharmacy and then moved to a hospital. And so I've been dealing with patients pretty much all my life. And even when I went back into the doctorate, I still maintained a part-time position, although coming in these places. So I've got a first-hand feeling and understanding of what patients go through. And we've had patients who've gone through drastic measures and really bad disease into simple ones as well, but across a range. So that kind of reshape your way of thinking. And then I've got some close relatives that have gone through some bad episodes on health as well. So when you accumulate your own family health, suffering from different conditions, into your patient that you see every day that looks after you, that you get paid to do a job, and then the job becomes, you're always asking yourself, well, what else can I do to help more? Then you realize that despite all the advancements that we have, we actually quite, I wouldn't say primitive, but the scope of medications is actually quite simple. So, for example, if you look into insulin discovery as injectables, it was in 1921. So that's more than 100 years ago, and we still inject the same insulin in the same way. So metformin, which is another drug for diabetes, or the first-line treatment, it's been around for 100 years plus. So we have not really that transformed into something very new. But however, there's a lot of work being invested in it, and there's a lot of ways around it. The advantage of FMT is that, first of all, you don't have to synthesize anything. It's human to human. So that is an environmentally friendly approach to start with. In my opinion, our heroes are not us. They're the donors. They're those who give up their time all the way and pay that expensive parking ticket into the Red Cross, and they provide the guts for us to use. So they're the kind of, so that if they are prepared to do this, then the least we can do is invest in making it happen. And that has been my drive for the last, million years. So I'm probably not that old, but
You certainly don't look a million years old, just for the record. Some really close to home motivations there for you. I wonder, the innovation as well doesn't happen in a vacuum. It's often the accumulation of years of dedication and pivotal experiences along the way. Could you share maybe a defining moment in your career that really highlighted the importance of pushing the boundaries in medical treatment technologies?
Sure. I guess it's can be put down to wouldn't be a single episode, but rather what was building up over time. It's very similar to Hani, I'm also a clinical pharmacist, worked in community and hospital. One of the advantages of clinical pharmacy is being frontline patient care. And I went through my undergraduate and I did a master of clinical pharmacy at Curtin while still maintaining pharmacy practice. And one of the things that always struck me as interesting is pursuing the boundaries or pushing the boundary of science to, find new discoveries, treatments, because a lot of the patients I was dealing with don't seem to be benefiting from cutting edge science that you come across in any newspapers and so forth. So I was always puzzled by the fact that we can put a man on the moon, but our knowledge of the human body is still quite primitive. And what we think we know, give it time, we turn back and say, no, we don't know. Sorry about that, we made a mistake. So one of the motivations for me to come back into research was to actually push the boundaries of science with that clinical background in mind, clinical pharmacy, because I want to, end of the day, it's the patients that have to benefit. So my moment would be that being in that pharmacy, wanting to push the boundary of science to the full extent and asking the question of why. What can it be better? Why does one patient experience this, the other patient totally different? What are we missing here? And that's the big motivation for me to basically pursue a career in research. And yeah.
All good research involves partnerships. Who are some of the partners that have come along for the journey to get you to this stage?
So we've been lucky enough that the Red Cross Lifeblood chose our lab and skill sets to utilise to establish this platform, and they're supported by the WA Health Department as well as the Rosary Health through funding.
I've got a question just in case it might lead to a few more people donating healthy poo. What qualifies for a good poo? What should people be looking at if they are thinking about donating to Red Cross Lifeblood?
Thank you. That's a very good question. What I would encourage people to do is there is no such a thing as a bad donor. Don't make an assumption that no one wants to poo. A lot of people do, and you would be surprised. We had the same thing in the organ transplantation space where people say, "Oh yeah, I can't. My liver is damaged. I can't." You don't know this, and always think about it as the other choice for that person is death. So the question then becomes is, would they survive with this optimum liver or gut or something else, or do they just die? So to do this, I think from my understanding is the Lifeblood, you can go and can get a car park there, just give it a go. You got nothing to lose, you're not going to charge anything or anything whatsoever. Give it a go, have a go at it, and then wait to see whether you're eligible or not. They will screen you put on other things as well. They've got a whole list of items. That's how it gets approved by the TGA for the work to get done here in humans. But once you're approved, you can be a lifelong donor and a real hero.
What I would like to add is, in the FMT space, it's actually a learning curve for all of us, for scientists, for clinicians, for donors, patients, funding and bodies. So, it's very important that people do donate because, like I said, it's a learning curve. We also don't know all the answers. And unless we get a lot of people turning up to donate, unless we get the ball rolling, we actually won't have all the answers of what is a good donor, what stool are we looking at, what effects would it have to benefit the patients ultimately at the end of the day.
Do you know if we're getting many donations at the moment?
No, there's a fair bit, but I have to say that the success rate is quite low. Maybe because we put the bar too high. I'm not sure. This is something that not in my hand at all. Red Cross has to deal with it, but they have significant interaction with the regulatory bodies, and they're being watched all the time. So whatever they do is being monitored heavily. And I mean, as of only yesterday, we got an email to change the platform a little bit because what we thought would be a good idea, the regulatory pathway said no, that's a bit too invasive. So we also being guarded by what's possible. I mean, sometimes the scientists and pharmacists tend to kind of really just give it a hell of a go, and it may backfire at times. So it's all about the balance. But exactly as Armin said, and I would like to echo that we still don't know a lot of things. Despite all the science and all this knowledge, very little, in my opinion.
Well, that's inspired me to donate. I hope plenty of other people do as well.
Fingers crossed.
Thank you so much, Armin and Hani, for coming in today and walking us through the fascinating world of gut health and your really innovative and important research. I can't wait to find out what's next.
Thank you for having us.
Thank you for having us.
You've been listening to The Future Of, a podcast powered by Curtin University. As always, if you've enjoyed this episode, please share it. And don't forget to subscribe to The Future Of on your favourite podcast app. Bye for now.